Hey, Gibson here. Today we're going to move into the second lesson on this unit of um, rational functions. The first unit we looked at the difference between inverse and direct variation. So today we're going to take a deeper dive on inverse variation functions, specifically one called the reciprocal function. So let's look at the objectives. Basically, we're going to look at what does the graph of a reciprocal function look like, and we're going to apply the same concepts we've been doing all year when we look at different types of functions, and that is to look at what are the different transformations we can make to those functions. So think of the transformations as reflection, stretch or shrink, shift left, shift right, up, down, those types of things. So some of that will be very familiar to you. What's new is what this reciprocal function itself looks like. So what is the reciprocal function? Think of it as the most simple function you could write for inverse variation. Okay, so here we see our equation y equals 1 over x. Okay, so in this case, our k value is 1. So this is, again, what we mean by the most simple function you could write for inverse variation. Notice the other restriction we have, of course, is that x cannot be equal to 0, because if we did that, right, we would have 0 in the denominator, and we cannot divide by 0. We get an undefined condition. So what does the graph look like? Well, often, right, when we have a new function, we can just start picking some points, plugging them in, and see what we get. So let's do that, right? We'll take these set of values here that I am showing in the table. So if we put in -4, it'd be 1 over -4, which would just simply be -1/4. Let's leave it as a function, right? So we can do that for the rest of these values. When we plug in a function like -1/2, remember we would be dividing by a fraction. How do we divide by a fraction? We multiply by its reciprocal, right? So what's the reciprocal of -1/2? It would be -2 over 1. So that's where we get the -2, -4, +4, +2. Okay, so let's put these on a graph and see what they look like. So let's go ahead and do that. Now, the graphs that we worked with so far, with some of the examples we saw in our previous lesson on inverse variation, where we had time and distance and speed, those were all positive values, right? So we only saw the graph basically in the first quadrant. But the reciprocal function, as we can see now, can have both positive and negative x and y values. So notice what we have here. We actually have two separate curves that make up the graph of the reciprocal function. The other thing to notice is now we have actually two asymptotes. Both the x and the y-axis are going to be our asymptotes. Okay, so here's our horizontal asymptote on the x-axis. Here is our vertical asymptote on the y-axis. So why is the y-axis an asymptote? Well, what is the value of the x-coordinate anywhere along the y-axis? It's 0, right? So we just said in the previous slide, one of the restrictions is we cannot divide by 0. So we can never allow the values to equal 0 for x. So that's what gives us a vertical asymptote on the y-axis. The other thing we can use to describe this type of function is that it has two branches. In a minute ago, I just said it has two curves, but the name we're going to give to each of those curves is called a branch. So the reciprocal function has two branches, and they're separated by the asymptotes. Now, when we sketch these, we're not going to have to go through and generate all these values that we did below in the table, okay? The key values that we can use are 2 points, 1, 1, and -1, -1 for the parent function. Again, the parent function is the most simple form of that. Okay, so all we really need, right, is to put those 2 points in, draw in our asymptotes, or at least recognize they're on the X and Y axes, and then we can sketch in our 2 branches, okay? Just be careful when you draw these in that you don't cross the asymptotes, right? They have to get close to, but not touch or cross over the asymptotes, okay? So sketching the reciprocal function becomes very simple, right? We just put our points 1, 1 and -1, -1 in, and draw in or sketch in those branches. Now, let's look at the more general form of the reciprocal function. And here, things should start to look familiar to you. Notice we have our a, h, and k variables in this function. And they do the same thing that they did in the other functions that we've studied, right? Whether they were linear or quadratic or radical or exponential, okay? So let's step through this and just remind ourselves what each of these do. So starting with the a value, if the absolute value of a is greater than 1, it'll be a stretch. If it's less than 1, it will be a shrink, okay? And we'll look at examples of that here in a minute. If it's negative, then that gives us a reflection, okay? So same thing that we've seen before. How about the h value? Well, this is our horizontal translation. And because the form has the subtraction in there, right, we're going to move in the opposite direction. So if we include the sign, if it's positive, we're going to shift the 2 branches to the left. If it's negative, we move them to the right. And then our k value is for the vertical. And here we just go up if it's positive and down if it's negative. Okay, so nothing new there in terms of what do the a and the h and the k tell us about the transformations that we can apply. So let's look at an example of each of these. Here's our reciprocal function that we want to sketch, y equals 4 over x. Okay, now the first step we're going to do is sketch in the parent function. Okay, so the parent function will always have a k value of 1. And let's sketch that in, right? We're going to put in those 2 points, -1, -1, 1, 1. We'll sketch in our asymptotes. And now we can draw in those 2 branches. Okay, so that's our starting point. So now the question is, what will be different if we change our k value, really it's our a value in the form that we now are using from 1 to 4, okay? So if a equals 4, remember that the absolute value is greater than 1, so that gives us a stretch. But what does a stretch look like for the reciprocal function? Well, here's one way to think about it, right? If we were to rewrite the reciprocal function in this form, right? X times y equals 4. Get my pen here. Right? So we're going to rewrite it in this form. Notice that the product of x and y always has to equal 4. Okay, so if you think about these 2 points that we used for the parent function, right? 1, 1, -1, -1. In those cases, both x and y have the same value. Okay, so we could rewrite this saying, well, if x times y has to be equal to 4, and x and y are really the same value, then x or y would simply have to be the square root of 4, right? If we were to replace y with x, we'd have x squared equals 4, and then we would take the square root. So the square root of 4, of course, is 2. So this means that when we stretch a value, we're going to move it from 1, 1 to 2, 2, and then we have to remember that we would also have, yeah, there we go. See the little animation there? Let me back that up and do it again. So we're going to move from 1, 1 to 2, 2. Okay, that's what the stretch looks like. Notice it kind of moves out from the origin along a diagonal line. And we want to find the points, right, where x and y values are always the same. Square root of 4 is also -2, right? So our second point down in the third quadrant here will move from -1, -1 down to -2, -2. Okay, so now we're ready to sketch in our final branches. So that's what it would look like. The branches will still be a curve that gets near the asymptote, but you notice they don't make that turn as sharply as the parent function. Okay, so there's an example of a stretch. What does the negative do? Well, if a is equal to -1, that gives us a reflection. But again, first step, let's put in the parent function. So we put in those 2 points, our asymptotes, sketch in the branches. Now, the -1 is going to reflect. So basically, we're going to take the branch and the 0.11 that's up in the first quadrant and reflect that down below into the fourth quadrant. We're going to take the branch that's in the third quadrant and reflect that up into the second quadrant. So what does that look like? Let's go ahead and do that. So let's take that 0.11 will then become 1, -1. Same thing with our other point, -1, -1 now becomes -1, +1. And now we can sketch in the new branches in their position after we reflected. Okay, so that's what a reflection looks like. The branches go from first and third quadrant to the second and the fourth quadrant. All right, let's look at some of the other cases. We have y equals 1 over x plus 2. So 2 is our h value, which means we're going to have a horizontal transformation here. So let's go ahead and again put in our parent function. Y equals 1 over x. So there's our 2 points, our asymptote, our branches. Okay, so we should be getting pretty good now at drawing that parent function in just literally a few seconds. And now, what does it tell us? So if h is equal to 2, it's a +2, right? And remember, we need to kind of go in the opposite direction. So we're going to shift everything to the left by 2 units. Now, the 2 points, we're going to move 2 to the left. But here's the question, which asymptote do we need to move also? So think about this. If we have a horizontal translation, it's the vertical asymptote that we'll have to move with the branches. Okay, so let's see what that looks like. Oops. Okay, so here's the horizontal, moving it out 2. Let's move the 2 reference points also to the left. Now, when you do this and sketch it in, I would definitely recommend putting those asymptotes in first, because once the asymptotes are there, it's much easier to see where I would sketch in the final location of the 2 branches. So now let's do that. Okay, so there's our graph with a horizontal translation. When we have a horizontal translation, right, we're going to move the vertical asymptote. So think of it as kind of, you have to move the opposite asymptote for what type of translation that you're doing. Okay, so there's an example of horizontal. Let's look at the vertical case, right? We have +3 as our k value. So same thing, let's put in our parent function. And then 3 is a +3, which means we're going to move everything up. So now, besides the branches, right, which asymptote will we also need to move? Well, since everything's moving up 3, it will be the horizontal asymptote that needs to move, right? So vertical gives us a movement of the horizontal asymptote. And of course, our 2 reference points. So let's do that. Let's move up the asymptote by 3. We'll move up our 2 reference points by 3. And now we can draw in our branches. Okay, so there's an example of vertical. So we've seen all of the possible transformations. We saw a stretch. We didn't look at a shrink, but a shrink works the same way, except it would move the reference points in towards the origin, right? It would be a sharper bin if we do that. I'm not sure. I may have an example coming up here. And then we've seen a reflection, a horizontal, and a vertical shift. All right, so let's try a few of these. If you just want to sketch these out in your notebook real quick, again, you really only need a couple points along your X and Y axis to be able to sketch these in. So we have y equals 9, over x. So first thing we're going to do is the parent function. So we put in our asymptotes, we sketch in our two branches going through 1, 1 and -1, -1. Now, what is the 9 going to do? 9 is our a value, right? So 9 tells us that it's going to be a stretch. Now, stretch to what? We're going to go from 1, 1 to 3, 3, right? Basically, you're going to take the square root of the a value. That will give you your new reference point. So let's plot those. We're going to move them from 1, 1 out to 3, 3, -1, -1 out to -3, -3. And that's it, right? This only has the stretch. So we can go ahead and sketch in our branches. Okay. All right, let's try a few more. Y equals -16 over x. So take a minute, see if you can identify what are the transformations that are going to be applied here. All right, well, the 16 is our a value, right? So that's going to give us a stretch, but we also have the negative, which is going to give us a reflection. So we have two things, a stretch and a reflection. Let's see what that looks like. So again, we start with our parent function, and then let's do the stretch first, and then we'll do the reflection, okay? So we're going to take the square root of 16 to find those new reference points. So we would have points at 4, 4, and -4, -4. But then we're going to reflect those. Okay, so let's put that on our graph, right? We start at 1, 1, and we're going to go out to 4, 4. But we're also going to reflect that. So we're going to go from 4, 4 to 4, -4. Let's do the same thing with our other point. First, we will stretch it out to -4, -4, but then reflect it up above the x-axis. All right, asymptotes, do they change? No, only when we have a horizontal or vertical shift. So the asymptotes stay the same place, and now we can sketch in our two branches. So there is a combination of a stretch and a reflection. All right, let's see if you can do this one. I'm going to pause for just a second and then just let the slides show you the solution here. And I'll stop talking. There we go. So everything moves to the left, including the vertical asymptote. There's a little typo here, right? This should be a +4, but remember we go in the opposite direction of the sign for horizontal. All right, let's see if you can do this one. Y equals 1 over x minus 3. All right, so there is a vertical translation moving down 3, including the horizontal asymptote. Okay, let's go on to another example here. Here we're going to have both a vertical and a horizontal. So see if you can sketch that in your notebook. What would that look like? So we're going to shift 3 to the right, since we have a -3 as our h value, and then up 4 since our k value is +4. Notice both the horizontal and vertical asymptotes also move. All right, let's try this one. We've kind of thrown a little bit of everything in here, right? We've got our k value, we've got our h value, and we have an a value greater than 1, so that's going to be a stretch. Okay, here we go. Now this gets a little tricky. Notice I did the stretch first, moved it out to 4, 4, then came down 2 and 3 to the left. So we almost wound up where we started in this case. Let's do the same thing with the other point. And again, this is where it's really helpful to have the asymptotes in their new location. Now we can see a little bit better how these curves would be drawn in. All right, so that's pretty complicated, right? We had 3 transformations. The only thing we didn't include in this was a reflection. All right, so that's it for this lesson. Pretty basic, right? The thing that's new is what does the reciprocal function looks like? And the key is that it has 2 curves, 2 branches, and both the x-axis and y-axis are our asymptotes. We can sketch it very quickly by starting with those points 1, 1 and -1, -1. So that's the new part. What we've seen before is how do we apply the transformations to that parent function. So stretch, shrink, reflection, horizontal and vertical shift. We've seen all those before. All right, so you have an assignment in Google Classroom. It's actually a Google quiz worksheet with a lot of multiple choice in it. It'll be a little bit easier than what you've been doing lately with writing everything out on a piece of paper. So go ahead and finish that up now. Thanks.